Okay, so let's suppose you had 6x squared plus 11x equal 10. 6x squared plus 11x equal 10. So you had something like this on your last test. What would you have done with this on your last test or on the test coming up? What would you have done?
Brought the 10 over.
Okay, so what kind of equation is this, first of all? Quadratic. And the only way you know right now how to solve a quadratic equation that has an x term, x squared term, an x term, and a constant is by factoring. That's the only way you know how to do it. Next week sometime you're going to learn about the quadratic formula. So there's another way you could do this, is using the quadratic formula. But you say you can bring the 10 over, so you're going to get 6x squared plus 11x minus 10 equals 0. All right? And so then you would factor this. So let's see, 3x, 2x, let's try those. For 10, let's try 5 and 2. And you know, based on our discussions in the past, that you wouldn't put the 2 in this parentheses, right? Because that would mean you could factor out a 2, which meant that the original polynomial, I could have factored out a 2, and I can't because that's an 11 right here. So you're going to put the 2 with this one and the 5 with this one. Now remember the last sign is negative, so that means these signs in here are different. One's positive, one's negative. And the outer, in this case, what's the outer right here? 15x, and the inner is 4x. So the larger of that will take the middle sign. So which one's going to take the middle sign? The 15x, so that's going to be the 5 right here. So it'll be plus, and this will be minus. Is that correct?
Yep.
Okay. All right, now again, you have time to check your work, so make sure that's correct. 3x times 2x is 6x squared using FOIL. Negative 2 times 5 is a negative 10, and the outer is now positive 15x. The inner is a negative 4x, and when I add them up, I get a positive. Okay, so I'm at this point. Now, what property do I use next? Zero factor property. So when I have 2 or more factors whose product is 0, then remember one of them has to be 0. So I'm going to say both of them equal to 0. And notice I went from a quadratic equation to 2 linear equations. And so I'm going to add 2 to both sides. So I get 3x equal 2. So what's one of my solutions? What's x? Divide both sides by 3. What's x? 2/3. Over here, I'm going to subtract 5 from both sides. So when I combine like terms, I get 2x equals a negative 5. So if 2x equals a negative 5, what's the other solution? What's x? What's the other solution? Negative 5 halves. So I get x to be negative 5 halves. All right, so those are your 2 solutions. All right, so that's a review from something we've had. But then let's look at number 2. Suppose in number 2, I had x squared minus 12 equals 0. X squared minus 12 equals 0. How are you going to solve that quadratic equation? That's not the difference of 2 squares. 12 is not a perfect square. So based on what we did last class period, what do you remember?
Put the 12 on the other side.
Okay, so notice that one of the differences between number 2 and number 1 was in number 1, when this is in standard form there, how many terms do you see? 3. Here, there, how many terms do you see? 2. Here, the x term's missing. So we saw that in the last class period that if I have some expression squared equal a number, a constant, how can I get that expression by itself? No. What did we do?
Square root.
The square root. That's one of the reasons I asked you to work on that worksheet. And I should have made it due tonight. So to get that expression, right now I'm squaring. What's the opposite of squaring? Square root. So you would take the square root of both sides. But when we took the square root of both sides, what else did we have to do? a plus or minus. Okay? So here you're going to get x squared by itself, so I'm going to add 12 to both sides. And so I get x squared equal 12. So remember, I'm trying to solve for x, so what's the next step?
Square root.
Take the square root of both sides. A lot of students forget about that plus or minus, so don't forget that, because you end up with two solutions, not one. So the square and the square root undo each other, so you get x equals plus or minus the square root of 12. Okay, that's where we're at. But you have enough knowledge now to know that I can go further with this. Why can you go further with this? What can you do at this point? Say it again. I can you got to use the correct terminology. I can simplify the square root of 12. All right, you must know the terminology. I can simplify the square root of 12. So the square root of 12, what perfect square goes into 12? 4. So 4 times 3, and the square root of 4 is 2, so that's 2 square root of 3. Because remember, the square root of 4 times 3 is the square root of 4 times square root of 3, and the square root of 4 is 2, right? Because 4 is a perfect square. So this becomes x equal plus or minus 2 square root of 3. So those are your two solutions. Now that's in compact form. In MyMathLab, they're going to ask you to write the solutions using commas. So in MyMathLab, you could say this. You could say x equal, you'll say x equal 2 square root of 3, comma, and what's the other one?
2x.
Negative 2 square root of 3. Okay? All right, so that's number 2.
Excuse me.
Yes?
Why we have to say negative 2?
Because that's your other solution. A positive 2 square root of 2 and a negative 2 square root of 2. You have two solutions. Okay, number 3. X squared equal negative 49. How do you get x by itself? No, I wouldn't. Okay, so you can't, if you add 49 to both sides, which is what he said, you would get this. But what would you do with that, dude? What are you going to do?
Yeah, you're right. Do square root.
Yeah, so if you did that, notice that you probably think, well, that's a difference of two squares, which it's not. This is a sum of two squares. And you remember the sum of two squares cannot be factored. So if you're trying to factor this, it cannot be factored. Now on your test, one of the problems is going to say solve this by using the square root property. So I need for you to understand the square root property. So the only way you know how to do this is to use what property? Square root property. So what do I do at this point? Use correct terminology. What do I do? Tell me what to do. Say it again. How are you going to simplify negative 49?
That is
Take the square root of both sides. Okay? That's what I need for you to say. So if I take the square root of both sides, what else must I write? Plus or minus. So the square and the square root undo each other. They're inverses of each other. So I get x equal plus or minus the square root of a negative 49. So that's where I'm at. Now what else can you do? Simplify the square root of a negative 49. Okay, I'm going to go ahead and rewrite it right here. So how would you simplify that? Okay, that's where you end up with those imaginary numbers. So the square root of a negative 49 is the square root of a negative 1 times the square root of 49. You learned last class period, by definition, the square root of a negative 1 is equal to what? I. Remember, that's not a real number. So we define it as I. So we're now talking about imaginary numbers. So these are imaginary numbers we're not going to deal with. So the square root of negative 1 is I. The square root of 49 is 7. But we saw that there is a proper way to write this. You're not going to say I7. You're going to say what? 7 times I. So over here, what are your two solutions? Plus or minus 7i. Someone else could have said this, though. They could have said x equals 7i, comma, what's the other one? Negative 7i. Okay? So in MyMathLab, when it says separate using commas, then that's the one they're talking about. All right, number 4. X squared plus 72 equals 0. All right. So how are you going to solve this quadratic formula? You use the only two things you know how. Which one are you going to use? Square root property. So if I'm going to use the square root property, what must I do first? Get x squared by itself, so I'm going to subtract 72 from both sides. All right, so I'm going to get, if I subtract 72 from both sides, I get x squared equals a negative 72. So if I'm going to use the square root property, I got to get that squared term by itself. Okay, what's the next step? Take the square root of both sides. So when I take the square root of both sides, though, what else must I write? Plus or minus. All right, so I get the square root and square root into each other, so I get x equal plus or minus the square root of a negative 72. All right. Now, let's talk about the square root of a negative 72. If you're having difficulty with this, then you really need to rewrite them as product of square roots. So in other words, you need to rewrite this as the square root of negative 1 times the square root of 72. That's what you would need to do first. We now know that the square root of a negative 1 is I. Now let's talk about 72. Can I simplify the square root of 72? Why? 36 is a perfect square that goes into 72, and always use the largest. So that's 36 times 2. And what's the square root of 36? So this is, so I'm going to write it like this for right now. So that's I times 6 square root of 2. Y'all agree?
Yes.
But there's a proper way, there's a better way that we prefer you write this. So rather than saying I 6 square root of 2, how do we talk about writing this? 6i square root of 2. All right. So your solution will be x equal plus or minus 6i square root of 2. Okay? All right, so let's look at number 5. Number 5. And we have this. We have 2x minus 3 squared equal 9. 2x minus 3 squared equal 9. All right. Now, the directions on your final and on your test may say this. It may say solve this quadratic equation by using the square root property. Now, first of all, you do see that this is quadratic, right? How do you know that this is a quadratic equation? Okay, so if I were to go off to the side and you see where I have that 2x minus 3 that's being squared, and if I multiply by itself, that's what that means, right? And if I FOIL, I get 2x times 2x is 4x squared. So I get a squared term, right? So that'll be quadratic. The outer and the inner should be the same. The outer is a negative 6x. The inner is a negative 6x. So that's a negative 12x. And then negative 3 times negative 3 is plus 9. So this will be a quadratic equation, right? All right. So that's quadratic equation. We're going to come back in a little while to because I want to show you something else about this, but let's just deal with this for right now. So we know it's a quadratic equation. The only method you know at this point to solve a quadratic equation is by factoring. And now what's the other approach? Square root property. For the square root property, in order to use a square root property, it has to be of this form. Some expression squared equal a constant. Now that exp is the expression. Some expression squared equal a constant. Okay? Do I have that here? Do I have an expression squared equal a constant?
Yes.
Yes. So I'm going to rewrite this over. And I'm going to take the square root of both sides. So I'm going to take the square root of both sides. And remember, when you take the square root of both sides, you got to say plus or minus. And then remember, the process is the same each time. The square and the square root undo each other. You're left with what expression on the left-hand side? 2x minus 3 equal. And then simplify, if you can, the other side. What is plus or minus square root of 9 the same as? Plus or minus 3. Okay, plus or minus 3. You got to be very careful with this because some people will forget about the plus or minus and they'll just put 3, and you're forgetting that there are actually how many solutions here? 2, not 1. Okay, now what I want you to recognize is this. 9 was a perfect square. I ended up with plus or minus 3, right? Okay, so when we did this one here, this right here, let me go to a different one. So when we did this one, we said that x was plus or minus square root of 12, right? So x was a positive square root of 12, and x was a what? Negative square root of 12. Okay? So basically, this part right here, when I said x equals plus or minus square root of 12, I could split it apart. I could say x equal square root of 12 and x equal what? Negative square root of 12, because that's what this is, right? And then I simplify. That would be 2 square root of 3, negative 2 square root of 3. Okay? I want you to notice that that's the same idea we're going to use here. So when I break it apart like this, when I write it as 2 separate equations, this means, this right here means this, that this expression 2x minus 3 is equal to a positive 3, and it's also equal to a what? Negative 3. Okay? And notice I went from a quadratic equation to 2 linear equations. And so when I add 3 to both sides, and I combine like terms, negative 3 and a positive 3 is 0. So I get 2x equal, I can combine 3 and 3, right? What's 3 and 3? 6. And then finally, what's the next step? Divide by 2. So what's one of my solutions? X equals 3. That's one of your solutions. Over here, how do I solve this equation for x? Add 3 to both sides. Can I combine those? Yeah, because what's a negative 3 and a positive 3? 0. And what's the next step? Divide both sides by 2. So I get x, the other solution, to be what? 0. So those are my 2 solutions. So x equals 3 and x equals 0. Okay? And you can quickly check this one. Let's check 3. What's 2 times 3? What's 6 minus 3? And what's 3 squared? 9. Let's check 0. What's 2 times 0? What's 0 minus 3? And what's negative 3 times itself? 9. So those are your 2 solutions. Now let's compare number 5 with number 6. So here's number 6. I have 2x minus 3, the same expression, the same thing on the left-hand side. But this time, I'm going to set it equal to 7. Again, what kind of equation is this? Quadratic. The only way you know to solve a quadratic equation is by factoring. That was the first approach we did. And now we also know what other way? Square root property. But in order to use a square root property, it's got to be a certain form. It's got to be something that looks like this. Some expression squared equal a constant. And is that what this is? Does that look like this? Yeah. So now what's the next step? Take the square root of both sides. So when I take the square root of both sides, don't forget the plus and minus, I get the square and the square root undo each other. So I get 2x minus 3 equals plus or minus the square root of 7. So that's where I'm at. Okay? All right. Now, remember, we got to solve for x. So think about what we did a while ago. So when I did this one, what was the next thing I did? I wrote it as two separate equations, right? Okay, let's do the same thing here. So 2x minus 3 equals what? Not 7. Square root of 7. 2x minus 3 equals a negative square root of 7. All right. What was the next step? It's very similar to what we just did. What's the next step? Add 3 to both sides. All right, so I combine like terms. I can combine 3 and a negative 3. That's 0. So this is 2x. Now, just curious as to what you're going to tell me to write here. What are you going to tell me to write on the other side? Okay, so someone says 3 squared is 7. What else? Anyone else? There's only one person that decided to say something? Three cube root of 7?
No, just cube root of 7.
So you think that's the cube root of 7?
No, just plus the square root of 7.
So you think, say,
3 plus the square root of 7.
okay, so he's saying it's this. Anybody else? So only 3 people said something.
I'm just gonna agree. I agree
You-
with the first one.
You agree with this one? Okay. All right. So that one's a correct one.
Because we
Guys,
are just adding.
Because you're just
So here you're okay, so when we did this one, this was 3 plus 3, right? 3 plus 3. 3 plus 3 is 6. Didn't you add 3 to both sides? So over here, aren't I adding 3? So when we did this one, you didn't say 3 times 3, did you?
No.
So why would you say 3 times the square root of 7 then? You got to make those connections. You're adding. You didn't say multiply, you added. So 3 plus the square root of 7 is not 3 times the square root of 7. That's a different operation. This is multiplication. This is addition. So 3 plus the square root of 7, this right here, can I combine these two numbers into one number? No. They're not like numbers. So all I can do is write this as 3 plus the square root of 7. And now, when we did this one, when I said 3 plus 3 is 6, what was the next step I did here? Divide by 2. So when I do this step, what should I do next to get x by itself? Divide by 2. So my solution then is x equals 3 plus the square root of 7 divided by 2. So that's one of my solutions. It looks different than the other one. So you see how this solution right here looks different than this solution? See, that was a nice looking number right here. X equals 3. 3 is a rational number. Rational. You see this right here? That square root of 7? The square root of 7 is an irrational number. So that's the reason why it looks like this. Now, but that's only one solution. So what's the other solution? How do I solve for x over here? Add 3 to both sides. Combine like terms. Now listen. So you see this right here? I was able to combine those because the negative 3 and a positive 3, those are like numbers, like terms. That's 0. Here, 3 and square root of 7, those are not like terms. One's rational, the other one's irrational. So all I can do is write it as 3 plus the square root of 7. So here, that's 0. I can combine those. That's 0. So I get 2x equal, and then this would be, how would I write this? minus square root of 7. And then what's the next step? Divide both sides by 2. So I get x equal 3 minus square root of 7 divided by 2. So those are your two solutions. Now in MyMathLab, when they ask you to write it as separating by commas, this is how you would write it. So somewhere in MyMathLab, when you write the solutions that involve fractions, there's a fraction symbol. So you click on that fraction symbol. You probably did that already. And then you put the numerator, and then you put the denominator. But you would separate it by commas. So in MyMathLab, you would say something like x equal, and then it will have a box here. And then you just put this. So you say 3 plus square root of 7 divided by 2, comma, and then the other will be 3 minus square root of 7 divided by 2. Okay? Now, let me go back and mention this about number 6. So, we talked about rational and an irrational number. So let's kind of review that for a moment, and then we'll come back to number 6. So when we deal with real numbers, and everything you've done at this point has been real number except what we talked about last class period. Remember last class period we talked about imaginary numbers? All right. So before that, though, everything we dealt with was a real number. So real numbers are either rational or irrational. So a rational number is any real number that can be written as a fraction, where the numerator is an integer and the denominator is an integer. For example, is 6 a rational number? Yes, because I can write 6 as 6 over 1, and both of those are integers. Is the square root of 25 a rational number? Yes, because what's the square root of 25? 5, I can write 5 as 5 over 1. Is negative 6 over 5 a rational number? Yes, because negative 6 is an integer and 5 is an integer. Remember, your integers are your whole numbers, 1, 2, 3, 4, and so on, 0, and the negative whole numbers, and so on. Okay, so those are your integers. Is 2.75 a rational number? What?
Yes.
Yes. Because I can write, because when we read, now I read it 2.75, but mathematically the way to read this is 2 and 75 hundredths, right? Place value. And then notice that's a mixed number, and I can write a mixed number as an improper fraction. 100 times 2 is 200. 200 plus 275 is 275 over, and this will be 100. So I have an integer over an integer. So any terminating decimal, a decimal that terminates, is a rational number, because you can always write a terminating decimal as an improper fraction. What about 0.3 repeating? So if you have a decimal that repeats, is that a rational number? No. Yes, it is. Because 0.3333 repeating is what fraction? 1/3. Okay. So if you have 0.252525 repeating, so any decimal that repeats, that's going to be a rational number. Now this one's hard to determine what that fraction is, but it will be a rational number. Let's talk about irrational numbers. An irrational number is a number that's not rational. So, for example, the square root of 7. The square root of 7 is an irrational number. Because if you put the square root of 7 in your calculator, this is what you see. 2.645751311, so on. There's no repetition of digits. You don't see a repetition. So this is a decimal that keeps on, that doesn't terminate, but there's no repetition. So that makes it irrational. In geometry you learned about pi. Pi is an irrational number. That's why we use a Greek symbol for it to represent it, because we couldn't represent it as a fraction. So we use a Greek symbol, but it's approximately equal to 3.14. So if you put pi in your calculator, let's see, where's pi on here? To the left. Okay, yeah. So there's pi, 3.14159265. So there's no repetition. It doesn't end, it doesn't terminate, but notice you don't see any part that repeats. So it's irrational. That's why we wrote it as a Greek symbol. Now in next semester you're going to learn about another irrational number, and that's that number e. So right above here you'll see e, but the alien. So you'll see e. So e is an irrational number as well. Okay? All right, so now let's go back to number 6 and number 5. So when I took the square root of 9 and I got 3 right here, and remember we're solving for x. So at this point, you are able to tell me if the solutions are rational or irrational. So when I got to this point, and I ended up with plus or minus 3, is that a rational or irrational number? Rational. So your solution is going to be rational, which means they're going to look like this, like fractions or integers. When I did this one, though, when I took the square root of 7, is 7 a perfect square? No. So I end up with what kind of solutions? Irrational. So that's why it looks like this. So you end up with irrational solutions. It's going to look like that. Okay? All right. Now, one other thing I got to mention, though, you see how we split it apart at that point, just like we did here? Whenever it's rational, you have to split it apart, and you have to tell me where those rational solutions are. But if it's irrational, you could have just done this. Let me just show you. You could have done this. See where we had that 2x minus 3 equal plus or minus square root of 7? You didn't have to split it apart. Since it's irrational, this is irrational. Irrational solutions. You could have just added 3 to both sides. And then these I can combine. These I cannot. So I get 2x equal 3 plus or minus square root of 7. You see what I did? 3 plus or minus square root of 7. And then how to get x by itself? Divide by 2. And so I get x equal 3 plus or minus square root of 7 over 2. You could have left it in that kind of form. Okay? Now, on MyMathLab, though, if you've read this on MyMathLab, you know you have to split it apart. You have to write them as 2 separate solutions. So in other words, you have to say 3 plus the square root of 7 over 2. And what's the other? 3 minus square root of 7 over 2. So there are 2 solutions. All right. Okay, let's look at number 7. Number 7. 4x minus 1 squared equal 81. 4x minus 1 squared equal 81. Is it in the form where I can use a square root property?
Yes.
Yes. So at this point, let's take the square root of both sides. I'm taking the square root of both sides. Now, what I have is that correctly written? The way I have it, you gotta look at what I have. Is that correctly written?
Plus or minus.
No.
Plus or minus. Okay, now the square and the square root undo each other. So what do I write on the left-hand side? 4x minus 1. What do I write on the right-hand side?
9.
Plus or minus
9.
9. Now, at this point, I'm going to ask you, is this rational or irrational solutions? It's rational. So since these are going to be rational solutions, I need for you to rewrite them as two separate equations, because you end up with rational solutions. So you should be able to tell me what they are. So 4x minus 1 equals two numbers. What's one of them? 9. And the other one's a negative 9. So notice I went from a quadratic equation to linear and just solve those linear equations. So what's the first step? Add 1 to both sides. Combine like terms. I get 4x equal, I can combine 9 and 1. What's 9 plus 1? 10. And then how to get x by itself? Divide both sides by 4. And so x equals 10 fourths. And you can leave it like this, or you can reduce. If you left it as 10 fourths, that's fine. If you reduce, you would say 5 divided by 2. All right, let's talk about the other. So over here, you're going to add 1 to both sides. Combine like terms, I get 4x equal, what's a negative 9 and 1? Negative 8. What's the next step? Divide by 4. And I get x equal, now I do expect you to not leave it as negative 8 or 4. That I need for you to know that's what? Negative 2. Okay. All right. Let's look at number 8. Okay, number 8. So, in number 8, let's suppose we had this. X minus 6 squared equal 72. X minus 6 squared equals 72. Can I use the square root property? Yes. So what's the step I would say? What would I say in words? I would do what to both sides?
Take the square root of.
Take the square root of both sides. So square root. I must remember to put a plus and minus. Now the square and the square root undo each other. So I get x minus 6 equals plus and minus the square root of 72. Are these rational? Am I going to end up with rational solutions or irrational?
Irrational.
Irrational, right? Why would you say rational? Is the square root of 72, is 72 a perfect square?
No.
No. So it's going to be irrational because I'm still going to end up with a square root in my solution. So that's an irrational number. But you remember, though, you can do more things with the square root of 72. You got to remember you can simplify now. You know how to do that. So let's go off to the side and figure out how I can simplify the square root of 72. Give me the largest perfect square that goes into 72.
36.
All right, so that's 36 times 2. So that'd be what? 6 square root of 2, is that right?
Yes.
Okay. So I get x minus 6 equals plus or minus 6 square root of 2. One more step and you're done. Because remember we said this. We said if we have irrational solutions, then I can write in that compact form with that plus and minus in the answer. So all I've got to do is to both sides now is to do what to both sides? Add 6. And now this is 0 right here, so I get x equal, and then how would you write the answer?
6 plus 6.
6 plus or minus
Plus or minus
6 square root of 2. Okay? And you're done. Now, in MyMathLab, they're going to ask you to write to separate the solutions using commas. So you could say this also. You could say, what's one of them? 6 plus 6 square root of 2, comma, what's the other?
6 minus 6.
6 minus 6 square root of 2.
Question.
Yes.
Why would you combine two
Because okay, so it's kind of like saying if I have 6 plus 6x, right?
okay.
Can you combine 6 and 6x?
No.
They're not like terms. Same thing if so these are not like terms. So if I have 6 plus 6 square root of 2, those are not like terms. We talked about last class period. We talked about square roots in terms of combining them. So these are not like terms.
Okay.
But if I have something like 3 square root of 2 plus 7 square root of 2, could I combine those? Yes, because both of them have the same radicals.
Okay.
So that would be 10 square root of 2. Okay? All right. Let's look at number 9. Okay, number 9, suppose we have this now. Suppose we have 2x plus 3 squared equal negative 9. 2x plus 3 squared equal negative 9. What can I do? Take the square root of both sides. Plus or minus, right? So the square root and square root into each other, so I get 2x plus 3 equal plus or minus the square root of a negative 9. All right, now let's talk about the square root of a negative 9. Let's see if you remember something about that. Okay, it's an imaginary number, very good. Because remember at the beginning of the lesson we talked about the fact that the square root of a negative 1 is equal to the imaginary unit I. And I can write the square root of a negative 9 as the square root of a negative 1 times the square root of 9, right? So that's I times 3, but we prefer to write it as 3i. So do y'all agree that 2x plus 3 equals plus or minus 3i? All right, now, remember, in the 8 problems we did a while ago, or not the 8 problems, but starting with, I guess, number 5 or so. Yeah, number 5. The solutions were real. Either they were rational or they were irrational. Are these solutions real solutions? No. They're what kind of solutions? Imaginary solutions. Remember they have the I. So you're going to do this one just like you did the irrational ones. So just leave it as plus or minus. So you're going to subtract 3. So you're going to say 2x equals. Now how would you rewrite this side right here?
3 minus 3.
No. Negative 3 plus or minus 3i. Always put the plus or minus term on last. And then one more step when you're done, what's the next step? What's the next step? How to get x by itself? Divide by 2. And so I get x to be negative 3 plus or minus 3i divided by 2. All right? You do it. You do the imaginary solutions just like you did the irrational ones. Now, in MyMathLab, they're going to ask you to separate them. So you would say negative 3 plus 3i divided by 2, comma, and what's the other?
3 minus 3
Yeah. Okay. All right, and then finally, let's look at one more, number 10. Okay, number 10. So, suppose at number 10, I had this. I had 3x plus 2 squared equal negative 24. 3x plus 2 squared equal negative 24. First of all, before we even go on, am I going to end up with real solutions or imaginary? Imaginary, because you know you're going to be taking the square root of a negative 24. Okay. So is it in the form where I can take the square root of both sides? Yes. All right. So I'm going to go ahead and do that. So I'm going to take the square root of both sides. Don't forget the plus or minus. Now the square and the square root don't do each other, right? So I get 3x plus 2 equal plus or minus the square root of a negative 24. All right, and let's talk about the square root of a negative 24. Let's talk about simplifying that. What perfect square goes in? Well, first I'm going to write this as square root of a negative 1 to the square root of 24. And the square root of negative 1 we know is what? All right, let's talk about the square root of 24. What perfect square goes into 24? All right, so it'll be 4, square root of 4 times 6. And what's the square root of 4? 2. But what's a better way to write I times 2 square root of 6? 2I square root of 6. That's what this is. So this becomes 3x plus 2 equals 2I square root of 6. Now, since this is imaginary solutions, just leave it. Oh, I forgot the plus and minus, didn't I? Okay, plus and minus 2I squared root of 6. Since these are imaginary solutions, just leave it as plus and minus. Put it in compact form. But I got to do 2 steps, though. What's the first thing I got to do? Subtract 2. So these add up to be 0. So get 3x equal. Now, how are you going to write? What's the best way to write the right-hand side? Nope. Negative 2 plus or minus 2I square root of 6. So negative 2 plus or minus 2I square root of 6. What's the next step? Divide by 3. Let's go ahead and rewrite this over. And now you have your solutions. So the 3's divide out. You get 1. So your solutions are negative 2 plus or minus 2I squared root of 6 divided by 3. Or if you want to separate them, what are they?
Negative 2 plus 2.
Negative 2 plus, you're right, I'm sorry. Negative 2 plus 2I squared root of 6 over 3. And what's the other?
Negative 2 minus 2I square root of 6 over 3.
Yep. All right. Okay. All right. So that should help you with that worksheet I gave out earlier.